G'day guys, Mr. Bennett here. Today we're going to be looking at another example of electromagnetic induction, and that is basically how motors and generators work. Alright, so essentially a motor, and we've got a very simple schematic here of a DC motor. What a DC motor does is it simply takes electrical energy and converts it to mechanical energy. So what we have in here is a permanent magnet, so you have a north and the south pole. You have a moving we have a current carrying wire inside that, which obviously produces a electromagnetic force, and so you can see obviously with the direction of the current going here that the force is up there. The current carrying this side will be going down, so therefore that's actually producing a clockwise motion. Other parts of this particular motor, you have these brushes which allow the direction of the current to change in this loop. Obviously you have to have some sort of electrical energy there, and notice there's a little split here, so you have actually a split in here on the commutator which allows the direction of that to change as it loops around. Anyway, I'm going to show you a quick video of how this works, keeping in mind a motor and a generator work exactly the same but in opposites, in terms of one takes electrical energy and produces mechanical energy, and the other one uses mechanical energy to convert that into electrical energy. Alright, so let's just quickly watch this video.
Basic structure of an electric motor. We can see the battery, the commutator, the brushes, the copper wire loop, and the permanent magnet. The brushes are attached to a wooden support, and the commutator is fixed to the loop of copper wire. The commutator rotates freely, rubbing against the brushes. Now when we pass current through the circuit, this creates a magnetic field around the wire, which interacts with the field of the permanent magnet to produce a rotation of the loop that looks like this. The electric motor and the electric generator are related like two sides of a coin. In general, the task of an electric motor is to convert electrical current into mechanical force. On the other hand, an electrical generator converts mechanical force into electrical current. So as you can see, we can simply rearrange our motor into a generator. In this case, we will provide the mechanical force with a windmill rotor attached to the loop and connect a bulb in place of the battery. We will leave the magnetic field as it is, and as the wind rotates the blade, an electrical current is produced.
Right, so in terms of you get the idea of how that works, so obviously if you have some mechanical way of turning that loop of wire in there, you actually will produce a current in there, but if you have a current going through that loop, you're going to produce mechanical force. Right, so that's pretty well as simple as it needs to be. What you'll need to be able to do though in this particular diagram would be to use your right hand palm rule to talk about the direction of the force that will be produced in there. So if I gave you a picture of that in a test, I'd be able to expect that you should be able to use your right hand palm rule to predict what's going to happen there with the direction of the force, but also the strength of force, using F equals BIL as well. Alright, so very useful. So if you start thinking about how we produce electricity, probably the most important part of that is the generator part. So simply if you're looking at a wind turbine, it uses that very simple process. Alright, so if you've got a conventional power station, all that does, it certainly heats up water by burning coal or gas or anything like that, and then that turns the turbine, which is simply one of these coils inside a magnetic field. Even if we start looking at nuclear energy, it does the same thing. Instead of you burning fossil fuels, it burns uranium, and so therefore that heats up water, produces steam, which turns a turbine. So essentially a lot of these particular types of energies do the same sort of thing, which is simply turning that coil of wire inside a magnetic field, which produces electricity. So if you think about how revolutionary that has been to our lives. You know, it's made a huge impact on what we can actually do in our everyday lives. So it's a really important understanding. Now, what I'd like you to do, if you haven't already watched the Faraday video from Paul Hewer on the paddler, I would like you to do that. Right, so that will certainly sort of explain the concept of what we're doing here. And I'll also do another demonstration in class to show you how this works as well. So anyway, good luck. It's a pretty simple concept, and I think it's something that certainly makes a lot of sense to me, and hopefully it makes a little lot of sense to you.